doing projections in Excel, first of all, just generally speaking, when you're putting together a pro forma, you're telling a story about the future. And it's a story about money. And so we're sitting here today at time zero, and we're going to be telling a story about some number of years. Maybe this is 5 years or something. And when it comes to cash flows, such as revenues and expenses, there is a common set of elements to those types of formulas that you can lean on when you're building out a formula. And the most basic two elements are some base value and a growth factor. And so the base value is going to be the output that's being measured, such as the rent, either the rent per square foot or the whole dollar rent for an entire suite or an apartment, etc. And then the growth factor, which may or may not be constant and compounded, could be unique for each year and compounded. Those are the two elements that you absolutely must have. And quite frankly, growth factor can be 0 for 1 or more years. Growth factor can be negative for 1 or more years. It doesn't need to be always positive. Rents don't always go up, right? Vacancy can skyrocket for some set of circumstances, and rents can stay flat, rents can go down. So keep that in mind. On a little bit of a more nuanced basis, when we're talking about building a formula from scratch, you have what are sometimes required, which we call start and stop timing triggers. And these are optional elements, and generally I'll accomplish this using the if function, which we'll look at a little bit now and in a lot more detail in a few minutes. And then sometimes you have what we call a periodic adjustment. So you might get operating expenses per square foot per year as your variable, but you're modeling monthly. So you would then need to divide by 12 to get to your monthly value if you're showing monthly. So that's something that you might have to implement. And last is what I call a distribution adjustment. Sometimes you have to apply a ratio for a particular discrete period of time, like operating expenses during the initial lease up of a newly developed apartment building. Maybe you only want to, charge 80% during X number of months, the first months of operation, and then you ramp that up to 100%, something of that nature. Definitely more nuanced. Again, at the most basic level, you've got a base value and growth rate. So let's use this as an example, and let's write a formula out here to project rent. And our base rent per square foot is $30, and that's $30 per square foot per year. The tenant's suite square footage is 20,000. We're assuming that the lease provides for 3% growth year over year, and that we're going to sell this building in month 72. The way that I found that I learned formula writing best through a lot of trial and error was to just write out a formula in natural language. And so that's something that we can do here and say, all right, what is it that I'm trying to do here? So I'm going to say the base rent is equal to $30 times 20,000, right? If I'm talking about whole dollars. So $30 per square foot times 20,000 square feet. And so I want to grow the base rent by 3% compounded annually, by 3% compounded through month 72, right? So there's an end point to my formula implementation here. And so that's what I want. And once I know what I want, then I say, all right, now let's translate that into an Excel formula using mathematical operators and using functions. And so what I'd like you to do is let's take a couple minutes and see if in cell Delta 49 here, you can write a formula taking this raw data and get it to populate in that first cell, and then copy and paste that formula out and see what you get. And so again, you can use as your guide this basic syntax here. Base value, growth factor. You may need a periodic adjustment. You do not need a distribution adjustment, so I'll give you that hint. You can ignore that. The solutions are below here, so you can always lean on that, reference that. Go ahead and try your hand at that for a couple of minutes, and then we can walk through it together. And it also sometimes helps me to just think about, before I even launch into a formula, if I were to graph this data series, what would it look like? So if you had, before we even dive in here, if you had to guess what this graph would look like, so this is a commercial lease for office space or retail space or what have you, what would this look like? Somebody tell me, should it look like this? Should it look like this? What do you think?
It should be the red because for each year, all 12 months should have the same rent.
Okay, very good. So that would be what's known as a step function, right? And so we say, all right, well, it's going to be $30 a foot per year here. It steps up and then it remains constant and so on and so forth. So I just find it helpful sometimes to just try to picture it visually first and then go into it. And then, if you are going to graph it, then you can say, all right, how did my graph end up looking? This graph's going to populate automatically based off of what you do. I'd like a volunteer. I'm in cell Delta 49 here. Tell me what I should type after the equal sign.
If, open bracket, D47, so the first month, larger than, and then I locked in D43.
Okay, good.
0.
And tell me what that does.
So that just zeroes out the values beyond the sale date.
Good, okay.
And then beyond the comma, I locked in D40, the annual base rent.
Okay.
Multiplied it with the tenant square footage in D41.
Good.
Divided that by 12 to get to the monthly rate.
Good.
And times that by the growth rate. So open bracket 1 plus locked in D42. Bracket closed to the power of open bracket D48, not locked in. So the year minus 1 and then close 2 brackets.
Beautiful. Thank you very much. So what he did is he brought this idea of the stop trigger to the front, and then we have the base value adjusted for the periodic nature given what we were provided with, which is $30 per square foot per year, grown at that constant rate raised to the power minus 1. And so it's always good just to do a little sanity check in your head, right? So when you see 50,000 in year 1, you say, all right, well, what's this annual rent? $30 a foot times 20,000 square feet, 600,000 a year divided by 12 is 50. So, okay, at least I'm starting out correctly. And then you copy and paste it out. And you take a look at your graph, you say, okay, this is what I just modeled, right? At $50,000 flat for the first 12 months, and then it steps up by 3% and so on. And then importantly, it truncates here, right? So here's month 72, and it stops. And that's because of that if function portion of the formula that was put in on the front end. And so that's one way to do that. I'm going to take out the if piece from the front here. So if I didn't do anything with the if statement and I just copied and pasted, it would just go out as far as my projection can support. But if this is not relevant to us, we do want to have that stop trigger element. And so the other way to do it is to do on the back end what I call a times if. If the month number exceeds the point of sale anchored, then multiply what preceded by 0, meaning wipe it out, force it to 0. Otherwise, multiply by 1. Okay, and so that's going to give us the same net result, which is this truncation at point of sale. So, as I said at the very beginning, there's almost always more than one way to get to your answer. And as long as it's going to work in all circumstances and you're comfortable with it, you're good to go.